In this video, we are going to talk about geometric applications of radicals, so problems that in a word problem setting involve using radicals. So one of the most common is using the Pythagorean theorem. So the Pythagorean theorem says if A and B are the lengths of two legs of a right triangle, then C is the hypotenuse, then A squared plus B squared equals C squared. You might be familiar with that. It doesn't matter which of the legs you'd label A and B. This is A, this is B, or vice versa. But C is always the hypotenuse, the long leg of the triangle, or the longest side of the triangle, and it's always opposite of the right angle. Okay. So when we put that into application here, if we say, well, let's figure this one out. If A is 5 inches, B is 12 inches, we're going to use this formula of A squared plus B squared equals C squared. So what we get is 25 plus 144 equals our C squared, or 169 equals C squared. We know that in order to solve this, we say, okay, what number when I square it gives me 169? And the answer, there are two. There is C equals 13 and C equals negative 13, right? But the question is, only one of these answers makes sense in this context, because what is C? Well, C is the length of this side. So therefore, C equals negative 13. We can't actually have that because you're not allowed to have a negative length. So C equals 13. Don't forget to put in your units there. Okay. Similarly, in this case, B is 18 centimeters and C is 82 centimeters. So in order to solve this, we would say A squared plus 18 squared equals 82 squared. So when I simplify that, you gotta figure out 18 squared is 324, and 82 squared is 6,724. That's not a good for. So then we solve this by getting our C by itself, right? So what we end up with is C squared equals 6,400. So when I take the square root, so asking myself what number when I square root, or when I square it, gives me 6,400. Well, if you're thinking about the square root of 6,400, that's the same as the square root of 64 times the square root of 100, which is 8 times 10, which is 80. And so C equals 80, and that is centimeters. Okay. The distance formula is another application of radicals, and that is the formula that allows us to find the distance between any 2 points in the coordinate plane. The first point we label as x1, y1, and the second one we label as x2, y2. And here is the distance formula. Okay, and so what we are, notice a problem here. This distance formula actually should have a plus here, I believe. Let me just change that because that was a mistake on my part. So we're just putting in a plus instead of a minus because the distance formula has a plus here, but these are minuses. Okay, so when you have your points and you're trying to find the distance between them, I don't care which one you list as x1 and y1 and which one you list as x2 and y2. It doesn't matter as long as you put them into the formula in the correct order. And so we just follow along here. The distance equals x2 minus x1, and then we're going to square that. And then we have y2 minus y1. Now we're going to square that. So this becomes 4 minus negative 5, so that becomes 4 plus 5. So that's 9 squared plus 12 squared, because 14 minus 2 is 12. So the distance equals the square root of 81 plus 144. And we can just actually figure this out. So 81 and 144 together makes 225, so distance equals the square root of 225, which is, of course, 15. Now, it might say the units that are involved in here, if it's inches or feet or miles, but if not, just go ahead and put units, because distance is a measurement and it needs something for a measurement to go with it. Similarly, I like to label the points so I remember where am I getting the pieces from. Okay, so this becomes 80 minus 88 squared, and 24 minus 20 squared, still under the radical, so we'll just make that a little bit longer. So this becomes negative 8 squared plus 4 squared. So remember, this is 64 plus 16, which becomes, the distance becomes the square root of 80. Now, I can leave this in radical form, but I do need to simplify it. Okay, so thinking about square root of 80, that's really the square root of 16 times the square root of 5. So square root of 80 becomes 4 times the square root of 5. And remember, we go ahead and put units on that. Okay. Now similarly, whenever we teach distance, we also often teach midpoint formula just because they go together. It does not actually involve radicals. Okay, so the midpoint formula here says you take your x1 plus your x2 and divide by 2, and your y1 plus your y2 divided by 2. So if I'm going to label my points, the midpoint, which is actually a point, I add my x's and divide by 2, and I add my y's and divide by 2. This becomes a point. I can simplify that to be 7 plus 5 is 12, 12 divided by 2 is 6, and 3 plus negative 7 becomes negative 4, negative 4 divided by 2 is negative 2. So the midpoint, if I were to plot these two lines, or 2 points, excuse me, and draw a line between them, this point 6, negative 2 would be the midpoint of that line segment. And finally, sometimes you're going to be using a little bit slightly different of a problem. So here it says the midpoint of the segment joining this point 5, 1 and some other point P is negative 3, 7. So this is actually the midpoint. Midpoint. Oops, I'm not spelling correctly today. So this is the midpoint. And then so we want to know, what is P? Well, P is some point we'll call x2, y2. And then this is our first point, x1, y1. So what I'm going to do is say my x2, my x1 plus my x2 divided by 2, and my y1 plus my y2 divided by 2. And this is my point, but it should also equal the point negative 3, 7. So I end up with two little mini problems to solve here. So this is my x-coordinate. This should be negative 3. And my y-coordinate should give me 7. All right, so how do I solve for this? Well, I'm going to multiply by 2 on both sides. So I get 5 plus my x2, and that equals negative 6. So then just go ahead and subtract my 5 from both sides, and I get my x2 equals negative 11. Similarly, I'm going to multiply by 2 on both sides here, and I get 1 plus my y2 equals 14. And then subtract 1 from both sides, and you get y2 equals 13. Since I'm looking for the midpoint of this problem, I need to actually answer my question as a midpoint. as an actual point. So I list it as, excuse me, I wasn't looking for the midpoint, I was looking for the x, x2, y2, which is my point P, and that is the point -11, 13. Okay. So if I look for the midpoint between 5, 1 and -11, 13, that ends up being this point here, -3, 7. Okay, that's all that I've got for this section. We will see you in the next video.